SUV.
Did you sell your bag?
Okay. See, that's more like it.
SUV.
You said CUV, doesn't it?
Oh, it is?
Yeah.
Oh.
And there's a screencast going.
I was whispered.
I know.
Okay, let's do this.
Let's finish the last two examples. All right, so with the first C,
Oh, why? Whoa.
Yeah.
so this is, it's power rule, chain rule,
Yeah.
but it just has a rational exponent, a negative rational exponent, but we still just treat it the same way. So there's a 3 out in front, so if we multiply
-1.
the negative 1/3, we get -1. Everything inside stays the same. Subtract 1 from the exponent, so it becomes -4/3 times the derivative of the inside. Okay, so 2x to the -1/2 will bring the -1/2 in front, so it'll become negative x to the -3/2 plus 0. And not a whole lot we can, I mean, if we go and try to change like the negative exponents, where would you begin? What do you think?
Like -1 over the square root.
Okay, so, well, we have a -1 and we have a -x, so the negatives will cancel each other out.
So it's 1.
Let's just start with x to the 3/2. That's easy to just switch to the denominator.
Isn't it negative?
No, because we.
Are you with like?
Yeah, if you have a negative here, and just look at the x to the -3/2, put that in the bottom. And then if we move this,
That's gonna be on the top, the 2x.
what's going to be,
Can you move the negative back to the top?
okay, so there's really not a lot that we can do to simplify this because we could rewrite this as an x to the 1/2 in the denominator, but otherwise there's,
Should we be done?
Yeah.
I would
What
be
you
I would be
accept?
okay with this,
Cool.
but if you want to write it
Yeah.
like that, that's just, we just took that extra step to get rid of the negative exponent, but because this is to the 4/3, honestly, I
And we
wouldn't
don't care
worry
whether
too
we,
much.
Whether we keep it as a fractional exponent or you put it in as like a cube root or whatever.
Yeah, if you want to leave it as 1/2 power versus square root, both are acceptable. All right, D.
It's actually C.
Second C, D. I made it into D.
Huh?
So you can do, okay, so we have a choice whether we want to make this x times x squared plus 1 to the -1/2 power or use quotient rule.
Do product this time because lots of quotient.
We could do product rule since we did quotient already. So I'm going to rewrite it before we do that. So we have x and then times x squared plus 1 to the -1/2. So when I find dy dx, and this will take up some space just to give you a heads up. Well, I'm going to write small, so I'm going to try to squeeze it all in. Well, because it's product rule, and then you have the chain rule within the product rule.
You do?
You do. So
Oh, you do.
Oh yeah.
You mean like?
remember
before
here,
horizontally a lot of
like if this
What?
is u
Me?
and this is v, right? So what is the product rule? It's going to be u v prime plus u prime v. Okay, so u is x, v prime. So we're going to be multiplying that by a -1/2 x squared plus 1 to the -3/2 times the derivative of what's inside, which is 2x, plus, and then I'm going to have 1 times x squared plus 1 to the -1/2.
Is that it?
Okay, so, yeah, that's it. That's,
All right, that's
I just
not
wanted to
terrible.
squeeze it in because of the screen pass. I can't go beyond that red line.
Is
Now
there a way
there's-
to make the red line bigger?
Are we screen
I can
casting?
readjust, but at this point I'm not going to. Okay, maybe before we factor out, let's just see if we can clean any of this up. There's really not much we can do. We would get a -x squared times x squared plus 1 to the negative 3 halves, and then this is just plus x squared plus 1 to the negative 1 half. I'm going to leave some space here. Just, again, I know we were having a little trouble with factoring out negative rational exponents. It's a little confusing. So if you look at the negative 3 halves and the negative 1 half, we want to factor out the one that has the smaller power. That's the negative 3 halves. So if I take out a negative 3 halves, so remember, when you factor, it's as if you're dividing. I mean, that's what factoring it is. Factoring is dividing out by a common term. So when I take that out, think of what would happen if I were to divide. Well, these would cancel, and I'd be left with a negative x squared. Plus, now what would happen here? So I'd have a negative 1 half minus negative 3 halves, so that would give us a positive 1 power. So that would give us x squared plus 1.
Wouldn't it be 4 over 2? Oh, it's negative 2.
Yeah, negative 1 half minus negative 3 halves would give us 2 over 2. Okay, well that just gives us 1 in the brackets, right?
So it's just x.
So it's going to be 1 over x squared plus 1 to the positive 3 halves. So that's in simplified form. Okay. Questions? So are we starting to understand a little bit better when we factor out that negative rational exponent?
Yeah.
Okay. Now, let's look at the homework.
Can you leave that up for just a second?
Sure. Just,
Can I write down some thoughts?
there. Everything?
Not everything.
21, 25, 31, 29.
Wait.
Should we make a list?
Yeah,
Okay, let's
I'm
make a list.
confused on
25.
13.
13.
On like I don't get I did the whole thing. I just don't get how to find where how to find where x is where the whole thing's defined.
Okay.
29. 41.
Somebody said 29?
We didn't get 29.
Oh,
29.
49.
29?
And 49. 62.
Should we just put all of them?
No. Can we just do 25? Just out of curiosity, how long does your battery last on this thing? Sorry.
Tech time with Jordan and Miss Casey.
I have not
Tested that.
tested it. Yes, thank you.
No problem.
The battery life, because I plug it in pretty frequently.
It was all the way over here.
So the math app, as far as I know, it's not released until
It's out.
the beginning. It is out already? I thought they said they were going to release it 2015. Somebody.
On Android, maybe.
Oh.
It's not out on Android. It's out on Microsoft and on
Darn.
iOS.
What's it called?
Photo map.
It's already
Photo
out.
math.
Google Maps.
It didn't come
Photo map.
Photo math.
Google Maps. Where'd that come from? Like no one said that. No one said anything close to that.
Love. Oh my god,
That
wait,
sounds
there's
like a
another
better
one.
name.
There's another one.
No,
I'm
my-
getting this one.
My screen factor is already.
It doesn't do
It's
calculus.
a trending search on the App Store. It's a trending
It's still cool.
Hey, I think it's pretty cool.
But don't tell your other one students about it.
Don't tell.
Hey, someone write
Don't tell my Algebra 1 students.
You have to be 4 or older.
Use the app.
I think we're good.
I'll tell my 3rd grade or 4th grade
They
brother
have
and sister
Wolfram
that
and
they'll
Wolfram.
love it.
Wait, how did you get it?
You just press download.
No, but I mean, like, where is it?
In the
Okay, are we done searching for an app that won't help us with the homework assignment anyway? Although,
Does it do handwritten fraction? Like
Yeah.
stuff or only like.
It's only not on no handwritten.
Well, about this, so Wolfram it's a site that you can type in, but you have to learn how to type the math notation. It will do all those prompts, and it'll do step by step. It's free.
Wait, this is so cool.
On to the calculus.
Jordan, help me.
Since we only have until 10, no, 10, 11:25.
No, we have reading.
Yes, 11th grade goes to Farber, 12th grade goes to Liner. 11th grade gets their pictures taken first,
We should go right.
and the seniors get their pictures taken from 1:10 to 1:25.
We have one sophomore.
Oh, sorry. Oh, sorry. Rita's room. Isn't that where you guys usually are? That's where that's the usual place where you guys go for your meetings.
Oh my god.
Cause Farber, you know, you guys are right next to.
It's solved. It worked.
What problem?
And like an algebra problem.
Oh, no, not the problem.
It's right here.
Try it.
F of x equals x to the fifth plus 2x minus 1.
But what are the directions on the actual problem?
I don't know.
It doesn't matter.
Now try it with calculus
Here it is.
problem.
It will work.
Oh, doesn't work for.
This is so fun. Does it work with cosine? Let's find out.
Okay.
So I got the whole like.
So you did so we have to find the slope of the curve.
I did everything.
No, can we do it? Because somehow I got my negatives.
Okay, so we want to do,
Me too.
so we're taking the derivative with respect to x on both sides. Notice here we have product rule and another product rule. Okay, so when I do the derivative of x, well, let me just think, this is u, right? This is v, and then when we do this later, this will be u, and this one will be v. So when we do the product rule the first time, it's going to be u, which is x squared, times v prime, so that's dy dx, plus, and then it's going to be 2x times y. So the derivative of x squared is 2x, y stays the same, minus, I'm going to put this in parentheses so I remember to distribute the minus sign. So it's going to be u, which is x, times v prime. So the derivative of y squared is 2y dy dx, plus, and then it's going to be u prime, which is 1, times y squared. So we keep v the same. That whole thing is equal to 0 because the derivative of a constant is 0. Okay, now I'm going to just, I have x squared dy dx plus 2xy minus 2xy dy dx minus y squared equals 0. So that's just distributing the negative. Now I want to get this term and this term on the other side. And then we also want to factor out dy dx. Are you okay if I do that all in one step, or?
Yeah.
So if I take a dy dx out of the left side, I'm left with an x squared minus a 2xy. And I'm going to move over the y squared and then minus 2xy. And then divide.
Yeah, that's what that seems.
I got the same answer.
That's fine. So that's switched around.
No, but one of them's switched both. No, it's like 2xy minus y squared.
Yeah.
2xy minus x squared, and what's on the top?
2xy minus y squared. Those are
2xy minus x squared. Same thing.
multiplied by negative.
Remember, a minus b.
Isn't the top and the bottom different?
Oh, if they're both different, they're actually the same. It's not.
No, I mean only the bottom's different. Is it only the bottom different?
Let me look.
Multiply by negative 1.
Why don't I see? This is 13. The same. I mean, it's switched around on the top and the bottom, so it's fine. It just means that they moved their dx, they moved dy dx to the other side of the equation. And they kept this other, basically they moved this and this over, but kept the 2xy and the minus y squared. It's the same thing. It's kind of like slope formula, right? y1 minus y2 over x1 minus x2 is going to give you the same result as y2 minus y1 over x2 minus x1. They're the same thing, so as long as both the numerator and denominator are both switched, you're good. This is fine. Does that make sense? Okay, next one.
Wait, we have to do the other part.
Oh, did I miss part?
Yeah.
Oh, it's defined at every point except where, yeah, so where
I
this,
get the x part, I just don't get the how they got the y.
so that can't be equal to 0. So if I factor out an x, right? Let's just say if I solve it for 0, you want to factor out x, so I know x can't be equal to 0 and x minus 2y can't be equal to 0. So solving for y, I can see that y can't be equal to 1/2 x. So it's defined at every point except for where these two things would occur.
Odin's right.
I just-
Except those two.
If I don't have enough room to write that, because like I'm at the bottom of the paper. And I
That's
can't
fine.
read.
You know what? As long as you write x can't be equal to 0 and y can't be equal to negative 1/2 x, that's good.
1/2, positive 1/2.
It's positive 1/2 x, or x over 2.
Yeah, okay. You
Oh,
said-
it's positive. Yeah, x.
Yeah, it's positive.
Yeah,
It's
okay,
positive.
you said negative.
Okay, does everybody have this?
Yeah.
Okay, next one is 21. Oh,
That's a fun one.
that's a fun one. So 21, looks like I'll have to write small. Let's see, 6x squared. So I'm going to take d dx of this. 6x squared plus 3xy plus 2y squared plus 17y minus 6 equals d dx of 0. And we're actually going to plug in a point at the end, negative 1, 0. Okay, so the first one, 6x squared. Whenever it's x, we just differentiate like normal. So this is going to be 12x. Now, with this next part, you have to use product rule. Just group the 3 with one of them. So I'll make it a 3x times a y, just to keep it easy. So it's going to be 3x times the derivative of y. You know what, just to show you a different way, I'm going to put y prime this time instead of dy dx. It's the same thing. Plus, and that's going to be 3 times y. Plus the derivative of 2y squared, so it's going to be 4y times y prime. Plus 17 times y prime, that'll be minus 0, equals 0. So you do have the choice if you want to write y prime. I usually prefer to do dy dx, but if you have a lot of writing to do, obviously it's easier to write just y prime instead. Now I want to get all the y primes together, which means I'm going to move these two over to that side. Follow along so far? Are you okay if I factor out the y prime also at the same time? So y prime,
So every time you take a ddx of something with a y in it, you have to do the like inside.
every time you have a y, you have to multiply at the end y prime or a dy dx.
It's not, no.
Every single time. Every
So
single
you do
time.
it normally and then just add the dy dx.
Yeah, exactly. That's where you're actually applying the chain rule. So anytime you do d dx of something with a y, it's just going to be 3. Just so, what's the derivative of 3y? It's 3 times the derivative of y. What if I did d dx of w squared? Let's say it's a different variable. Then it would be 2w times w prime. So whenever these variables are different, right, when they're not the same, you have to do the chain rule.
And so for we only get 3y in the third term because it's the product.
That was the product rule, and you kept the second part the same.
Got it.
That's why. And then we're going to move over, negative 3y minus 12x, and then divide. So y prime is negative 3y minus 12x over 3x plus 4y plus 17. Now we want to plug in. So I want to evaluate dy dx at, what was it, negative 1, 0?
Yeah.
So this will be 0 plus 12 over negative 3 plus 0 plus 17, which gives us 6/7. And then what? We have to find the tangent line and the normal? Okay. And what would be the normal? It would just be the negative reciprocal. I'm guessing, did they leave it like this or did they
Yeah.
put it in?
They distributed it.
They distributed? Fine, whatever. Same
They
thing.
always do that anyway. Is it wrong to put y minus 0 or is it just?
No, it's fine.
I just do this to make sure.
Okay. Same thing. All right, questions there? Did we just get a little mixed up with some of the product rule? Or is just, got it. Okay, so we're good with that? I can erase. Next one is
Fun one, 25.
25.
It's another fun one.
Oh, that's another fun one.
That's fun.
All right, so I want D.
29 up there, that's a fun one.
Where's 29?
It's up there.
Oh, it's the second derivative. Yes, I
Yeah.
see that one.
Yeah, we're gonna do it.
It's just long. It took a while.
Okay, and this is another one where we have to find the actual tangent and the normal at a particular point. Okay, so the derivative of the left side is just dy dx. I'll write y prime just to save some.
I don't like the
Spice
notation.
it up a little.
You like dy dx better?
No, I mean like my y's and my dy and dx, my y's always look like x's. So I
Oh,
get
so it looks like
confused.
dx over dx.
Sometimes it just looks bad.
Okay, this is the chain rule. So we have to do the derivative of the outside, so that's going to be step 1. And then step 2 is the derivative of the inside. Right? Okay, so the derivative of the outside, the 2 just comes along for the ride. It does not change anything, so it's 2 cosine.
Those.
Everything inside stays the same. Now we're on to step 2. So we did derivative of the outside, derivative of the inside. So the pi x, so the derivative of pi x would just be pi minus derivative of y would be dy dx. Good.
And then I got stuck.
Yeah, same.
Yeah.
Okay. This whole thing is one term that we're going to multiply
Yeah, just
to both terms. So we're going to distribute it.
Since when do we do that?
Yeah,
We just have
how do you
problems.
know when to distribute and when not to?
We've never done this. We never distributed.
Okay,
We just put
so-
everything in front.
Well, I can't.
Fine, don't cry.
Here we go. Here's your example where you have to distribute.
Is
So
there a
it's gonna be-
rule to distribute like when you have to y prime in the other one?
Well, you
or-
should recognize that 2 cosine of pi x minus y is one whole
I
term.
did that. I would've
And
put-
do
I
you
would've put
recognize
the
that
other one
pi
in front.
minus y prime are 2 terms? It just, it's basically the same as if you have 2 times x plus y. It just doesn't look that simple.
Oh, we don't
Pi
have to
x minus
distribute.
y are 2 times 2.
Huh?
Pi x minus y are 2 times 2. That's just confusing.
Pi.
Like 2 cos and then.
Yeah, but it's cosine of a quantity. So it's, that cosine of the quantity means it's, this is all one term. That's 2
I think
terms.
I spoiled it.
It just looks complicated because what you're taking the cosine of. But remember, that cosine of is still one term. This whole thing gets multiplied to the pi and then multiplied to the y prime. Okay, so we didn't do an example of this yet, but here we have one. So it's going to be 2 cosine. I don't know. Remember how far advanced I prepare? I don't remember what I put on your quiz.
Oh, jeez.
Minus.
We can just open it up, put it on the screencast, take a look.
y prime times 2 cosine pi x minus y. Honestly, you can put the y prime after. So now I'm going to add this to this side. So it's going to be y prime plus y prime 2 cosine pi x minus y is equal to 2 pi.
Can we not have a
Yeah, no,
ever
please
again?
don't.
Oh, guys, my goodness. Factor out the y prime. And then divide. Oops. So we get 2 pi cosine of pi x minus y all over 1 plus 2 cosine pi x minus y. You probably would, I wouldn't give you a, I would give you a problem where maybe you have to distribute, but it wouldn't be quite this complicated.
We
But
cancel.
like, the problem, like,
Can you cancel?
No.
No, there's a plus sign there that prevents us from
Oh,
canceling
yeah.
anything. If that plus sign was not there, then it probably wouldn't be an implicit differentiation to begin with, no.
but there's kind of a lot of times where we had like terms that have like, is it like x plus y, where we haven't distributed. So how do we know when to distribute?
Well, because we're solving for y prime. If y prime was by itself on one side, then I would have just left it. But because I had a y prime on the left side and the right side, and I have to try to figure out how to get all the y primes together, I have to distribute it.
Because like my first instinct would have been to divide though, like y prime minus, I mean divided by,
Yeah, but that won't get,
the same.
because this y prime is here, and I have to try to get it with that y prime, that's where it gets complicated, and I need to try to get, anytime you have that, you want to distribute and get
Okay.
everything on one side. Okay, so now I want to plug in 1, 0. So it's 2 pi cosine, well, that just becomes pi over 1 plus 2 cosine of pi. What's the cosine of pi?
Negative one.
-1. So I get 2 pi times -1 over 1 plus 2 times -1. So we get a positive 2 pi because we get negative 2 pi over -1. Now remember, that whole thing gave us slope.
And then you just.
So this is m, and the point was 1, 0. So our tangent is y minus 0 equals 2 pi, and then x minus 1. And then the normal is -1 over 2 pi, x minus 1.
What did they ask for?
Yes, Emma.
Just a random question. Are we gonna get our quizzes back today?
Did we get them back?
Oh, I never gave him back?
No.
Oh, I have them.
Okay.
But you saw the grades for them, and
Yeah.
they're on haiku?
Oh, actually.
You showed us.
No, I didn't.
I think you showed them to us.
Yeah, you showed them, you didn't post them.
Okay. Okay, so 29 was the one that really,
Yeah. 29.
No, we just did 29, 49. Oh,
We
yeah,
didn't do
29,
29.
sorry.
29, because that was the second derivative.
29's long.
And I may
They
need,
didn't
I
say
may
it
need
about
37 of them.
Just out of curiosity, do you have a Word document file for the practice quiz?
I do, but I don't have it posted.
Okay.
Month live.
Email me, and I'll take care of it.
Thank you. You do realize that did absolutely nothing worth your time.
Okay, derivative of the left side, 2y,
Or 2y.
it doesn't matter, dy dx, or y prime. Practice using both, it's good. Y prime saves a tiny little bit of writing, but derivative of x squared is 2x plus 2.
The first part's easy.
So dy dx is equal to, are you okay if I reduce it at the same time, x plus 1 over y. Okay, now that's dy dx. So if I now take d dx again,
Would you do that way instead of the quotient, instead of the product rule? Yeah, let's do quotient next time.
this would be, again, it's just preference. It's
I tried to
about,
do the product way and I couldn't get it.
It probably was harder,
Yeah, let's do quotient.
quotient rule would be the way I would go through this one.
cause they're simple terms.
Because, well, not only that, but you also have, this ended up being a fraction.
Yeah.
So when you get the fraction within the fraction, you just find common denominators and simplify it that way. So I think that's a little easier rather than trying to have to factor, plug it in, and then simplify. So here, this gives us the second derivative of y with respect to x with respect to x. That's really how you would read it, but this is how we write it. Okay, low, d high, so that's easy, y times 1. Take high, d low. The derivative of y is
dy
dx.
which is,
Cross the line and square the low.
So then you take that.
Now we take the x plus 1, and we're going to plug it in for dy dx. So I have the second derivative. It's going to be y minus x plus 1 times x plus 1 over y. Now there's a couple ways I could
can you just move the y? to the
simplify
bottom?
this.
Just make the y times by y.
If you multiply everything in the top by y and everything in the bottom by y, that will simplify it for you. See, as long as you multiply the top and the bottom by the same thing, that's another way to do it. Or you could find a common denominator, blah, blah, blah. Okay, so what do we get? We get,
Oh, the answer in the back messed up, they only gave us the first derivative.
Yeah.
oh, you had to find the second also.
Yeah, but I did that, cause that's what the
It
instructions
was
said.
in the book, in what's called, it was in the.
Solutions manual, I know, but I don't think it had a y square. Did it?
Yeah, it was y cubed.
But on the
This
top,
is
it's
what
y
it should
squared.
be.
No, it's, yeah, y, that's x, that's squared.
What's wrong?
I don't remember seeing a y squared in the solutions manual. In the top.
They just leave it as, it's y.
Oh, I see, I see. So, since y squared, I see what they did. Okay. They simplified it further. So remember our original equation? They took it a step further. What was our original equation? It was x squared plus 2x. So if I replace y squared with x squared plus 2x, and then I FOIL that out, which will be a minus x squared, a minus 2x, and a minus 1, we'll see that these will cancel.
Oh, yeah.
So you get a negative 1 over y to the third. That was,
No, wait, that was, but,
that's what they should have had. That's what they had in the back. Or at least that's what they have in the teacher's book. That's not what they had?
in the solutions manual, it had the one we had, but I don't think it had to put the y squared. I don't remember seeing y squared.
Yeah, there was one.
Wait, in the
What?
solutions manual, in the
So
PDF.
we're supposed to go this
Why
way
is-
further?
So can.
This is what I have in the teacher's book. They-
The solutions manual was different, I'm pretty sure.
Okay.
I don't know what it said, I
Can we
don't know
keep it
what
at
I
y
put it.
squared minus x?
Yeah,
squared?
so in the teacher's book, they actually have this, and then they wrote that that's equal. I would, usually they would just have it stop here. I understand what they did. I mean, we'll have some practice with the AP type problems later on in the year. Right now, it's a little difficult to do AP practice right now because you're just in the beginning processes, and then once we put it together with all the other pieces, then you'll be able to do some, I mean, right now you could probably do a few of AP problems, but not many.
You did cheat one.
Sorry.
That's really
Don't go and
scary.
take the AP test yet.
That's really scary, actually.
With what we have now, what's the highest score we could get on the AP test?
A 1.
Yay.
We'll get
Is
there.
there a zero? Don't we end a few months early? People get zeros.
I don't think you can get a 0. I've never heard of somebody getting a 0. I think you get,
How did the class do last year?
I did really well.
Well, it's also like a class full of my guy.
A lot of people got, there were quite a few 4s. There were more, I was hoping for more 5s, but I should probably. No, there was more than one. I don't remember off the top of my head. It was complicated because the kids that went on March of Living, when they came back, they were, let's just say, not into the AP exams.
Mhm.
One decided to cancel their scores.
You mean
One
that-
showed up and
Wait,
just,
what do you mean
How do you
cancel?
you can cancel them.
After?
No, you go in, you sit there through the AP, and then you contact the, and you cancel it after you take it. So,
They don't do this.
third,
Wait, what about
this is
4?
49. Did I skip 41?
Yeah.
Oh, that's too bad. Why, was 49 easier?
No, I just think 62, so.
Is 49 the one following 41?
Yes.
Yeah.
Oops. I have a practice quiz, by the way, so before you leave, if you want that. Find UIDX. Okay, so 3 gets multiplied to 3 halves, so that's going to be 9 halves, right? Cosecant x to the 1 half. And then what's the derivative of cosecant?
Negative. Cosecant times cotangent. Negative 9/2.
So, yeah, there's a negative 9 over 2. Oh, and then everything's in the top. So it's oh no, it's a square root or cosecant to the 1 half.
They put it to the third.
You
Yeah,
just
because-
Right, this is to the first. Oops, a first power there. So they just made it 3 over 2?
Then you have
It's
to-
a negative though, so negative.
No, the cotangent's still in it.
And then cotangent x.
But if you multiply,
negative
if
one
they
should not.
distributed out the cosecant.
Why would I want to do that?
But isn't that how you got the 3 over 2?
I would not want.
No, because you're multiplying that by.
What do you mean there's nothing to there's no plus or minus sign. That's just a
But
negative.
aren't you so you're multiplying cosecant by cosecant times cotangent, so wouldn't you have to multiply? Oh, no.
Are you just saying never mind, or are you okay with that?
I'm not a bird.
Sorry, I know I'm going quickly. I'm doing a screencast so you guys can, I'll post it so you guys can go.
And that's the answer, right, for 49?
Sure.
Because I circled, I have
I hope so.
We need to find what's about the points.
Does anybody know?
Oh.
Okay, it looks good.
Oh, you did all that already? I didn't even,
Points or
I didn't read the question.
Oh, there's points? Oh, find the 2 points where the curve crosses the x-axis. Okay, so where does it cross the x-axis? So we need to go back here. So where does this cross the x-axis? When y equals 0. So when x squared equals 7, so x equals plus or minus root 7. So root 7 comma 0 and negative 7, 0. Okay, plug those in. And then, what is the common slope?
-2.
There you go. So just, and then what was 62? 62 was
Find the
second derivative.
The first derivative, just to save time, the first derivative was y minus 2x over 2y minus x.
Okay, so 62, you have to take the second derivative. I'll see if I can, oh, it's y minus 2x
That's the second derivative.
No,
over,
that's the first derivative.
no, yeah, this is the
So we're
first
just
derivative,
taking
so
the
now we're going to do
derivative.
the derivative of this.
Wait, so how do we find it when it crosses the y-axis? You just hit y to 0? You just put it y.
Yeah, plug in y equals 0. Okay, I'll see if I can finish that. I don't want you guys to be late here. Okay,
We're going to big.
How does x squared equal 7 if y equals 0?
You're supposed to go straight there. And juniors have your picture first.
So, what am I-
Walker,
It's
So,
when.
should I still turn this in?
Well, like, how- but-
Should I still
so if
turn this
you
in?
plug it
Friday
wire
or
with-
would-
Where are we going first? I'm confused. You plug
You're
in
going
line
to, everybody
and
goes to their class meeting location, and then they'll call you till you get your picture.
Well, I think we're
Oh.
just straight there.
Oh, are you?
That's
Ours
when
is
it's
the
at
first
the
picture.
Okay.
Yeah.
Okay, so.
I'll get your backup.
Home
Just pass those around.
Little slice.
The review is optional, it's just, you know, if you wanna do well on the quiz and you wanna know what's on it, then.
And the answers are online.
Sure.
Do you mean this?
Oh, they're, sorry.
Oh.
I have 2 copies of the solutions.
Are they online?
They will be, when I have a moment.
Where are they?
The worksheet,
Our business, like Thursday. Yeah.